Yeah, it's good. I have no idea what day it is today. Just doing questions for my review, just to get a better understanding and to challenge myself to kind of explain topics because this kind of course is something that my friend said I need to know for like the um, exam that I have coming up for like post secondary. Well, no, not post secondary, like postgraduate, I think it's called. But yeah, so I just wanted to kind of challenge myself, work on my communication because I also got a new tutoring job. Currently, I am a tutor at Kumon, but it's kind of irrelevant right now. But anyways, so this is again continuing on with the chemical equilibrium. This is the unit I'm in during school, like during the course I'm doing right now, and it's more focused on acids and base equilibria. So I guess we could just get started, right? Just yeah, get into it. So the pH is what we need to find after we add 0.15 moles of NaOH to a 1 liter solution containing 0.05 moles per liter propanoic acid and 0.080 sodium propanoate. Okay, so solid NaOH. So first we could just say right off the bat that this is a strong base because that's a group 1 ion attached to OH. So we have a strong base. So now with propanoic acid and sodium propanoate, this is a buffer because we have the acid and we have the conjugate of the conjugate base of that acid. So we're putting it into a buffered solution. So what will happen is that this strong base, it'll react with the weak acid and produce the weak base, basically. So I'll just kind of write that down simply. Strong base react with weak, bro, my bad. It's been a long day. Weak acid. Bro, I'm actually writing everything backwards. Acid to produce weak base. So that's kind of the entire gist of what we're going to be doing. So in order to do that, we're going to need to do an ice table. So the reaction that we're going to be dealing with here is they already gave us the formula, which is helpful. HC3H5O2. So this is the acid. And now this acid will react with the strong base. This is kind of like this sentence here. Maybe I'll just change the order so it's makes more sense. So OH minus plus the acid equilibrium will produce C3H5O2 minus, which is the propanoate without the sodium because we don't really need to mention that, and then H2O, which is again kind of irrelevant. We don't have to worry about that. So now just starting with our ice table. I don't really like this line. Lock in, bro. Bro, it's so hard to. Oh yeah, I could look at just make it a straight line because now it's an iPad, but still getting used to drawing on iPad. But anyways, so H2O, we don't have to worry about this. So OH minus, that would be 0.050. Wait, no, not 0.05. That would be 0.15 moles, because this is a 1 liter solution. So 0.15 moles per liter will still lead us to 0.15 moles. We'll just keep the entire thing in moles, and then HC3. Bro, did I write this wrong? O2. What would that be? So we have 0.05 moles per liter in 1 liter. So that would just become 0.05 moles. C3H5O2, we start with 0.080 moles per liter, but it's in 1 liter, so it'll just be 0.08 moles. But we don't need to, we already wrote the unit somewhere else. So now from this, we need to determine what the limiting reagent is, or what the limiting bro, I need to work on that. But anyways, so clearly, hopefully it's obvious to you that the limiting reagent of this reaction is the HC3H5O2. If you're wondering why, it's because 0.05 moles is smaller than 0.15. And because this is a strong acid, it'll continue on in a to completion. So you'll realize what the issue is with this after we write this out. So what you'll notice is that the limiting reagent, or the amount of acid, was less than the amount of hydroxide moles there were. So this reaction couldn't go fully to completion. So what we're left with is just a concentration of hydroxide ions. And with the concentration of hydroxide ion, or the moles of hydroxide ions, we could determine the pH simply through that. So if we know that it's 1 liter of solution, and we have 0.10 moles, then 0.10 moles divided by 1 liter equals 0.1 moles per liter. So we can find the pOH from this, because this is again OH minus concentration. So pOH equals to negative log 0.1. This is equal to 1.0. And then to find the pH, finally, it's just pOH plus pH equals 14. So to find pH, it would just simply be 14 minus 1, which is equal to 13.0. And that is our answer. That's what the pH is. So yeah, that's pretty simple. On to the next one. Okay, so here is the next question. Two solutions are mixed. We got a acid and we got a base in differing amounts. What is the pH of the resulting solution? Okay, so HCl is a strong acid. NaOH is also a strong acid. So the reaction we have here is just strong acid plus strong base. So what we need to do for this is just find out which one would be in excess. Would there be more H plus ions, or would there be more OH minus ions? That'll determine if the pH is acidic or basic. So what I think is the best method of action, or what the method is just to find how much, so the first thing is to find how much H plus ions there are, moles, and then find the moles of OH minus, and then from that we could just see which one is bigger, and whichever one is bigger, that will be the excess, because the OH minus will react with the H plus ions to leave over the excess of whatever is left. So I guess we'll just start with the strong acid first. So we have 0.10, we don't want to write that, 0.1 liters of HCl with a pH of 2.50. So to find the H plus concentration, simply just put that 10 to the power of negative 2.5, and you should get a value of 0.00316 moles per liter. Boom. That's easy. So now concentration, C is equal to N times V. We need to find, what the heck am I doing? N over V. So N is equal to C times V, therefore 0.00316 moles per liter multiplied by the volume, which is just 0.1. Should just get one more decimal, 0.000316 moles. This is the moles of H plus. Boom, that's part one. So now the second part is just to find the amount of strong base. So we got NaOH with a pH of 11. So we're trying to find the concentration of OH, or the moles of OH minus. And in order to find that, we need to first find the concentration of OH minus. And how do we find that? We have to put it to the power, similar process to the first thing, just put it to the power 10 to the power of the pOH, which is the main difference, because we're trying to find the OH concentration. So to find pOH, that's simply just 14 minus 11, which is equal to 3.00. So we just put 10 to the power of negative 3. You get 0.001 moles. Now simply again, N is equal to C times V, which is 0.001 multiplied by 0.1 liters. So we should get 0.0001 moles. This is NOH minus. So now which number is bigger? Well, there's more H plus ions, so we just subtract the two. So from this we already know that the solution will be acidic because we have more H plus ions. But anyways, we'll just write it out. 0.000316 moles minus 0.0001 moles. So this is H plus OH minus. We should get 0.000, but maybe I should write all this in scientific notation. H plus. So now we need to find the pH of the resulting solution. Resulting solution will have a different volume than each individual one. So we have to add the two volumes. So we had 100 mils of NaOH, 100 mils of HCl, so that's 200 mils, that's equal to 0.200 liters. And then we had 0.000216 moles of H plus, so we can find the concentration of H plus really quickly just by dividing the two. From that we should get 0.00108, but this is so tedious. 108 moles per liter. Now from that, just substitute it into the pH. 0.00108, which is equal to 2.97. That is our answer. So honestly, today was really easy. I'm really happy that it was easy because I have a lot of other stuff I need to do. But yeah, quite simply, these two questions were just pretty simple. So that's all for today, and I'll see you for the video tomorrow. Goodbye.